Okay, the purpose of this video is to talk about the flow model, and this first clip, we're just going to introduce what this is. So this is, there's 3 samples that we're going to be working with. This one is C, so the flow model is sample C, and it's going to be helpful to have from Polylearn the sketch. So have this sketch, because you guys are going to draw the flow net on this sketch. Everyone will have their own flow net. And then also the data sheet that we're going to be using for the flow model is important to have. So have this one out because I'm going to refer to it as well. And we're going to gather, I'm going to write the data down on the board over here, and then you guys can transfer it onto the sheet. Okay, so this is the flow model. We have, for this one, we have 2D flow. So we have the water, you can see the head up here, it's flowing down through the sand. This part right here is a piece of plastic, it's a sheet pile, it stops right there. So this water has to flow down and over and up through the sand over to the tailwater side. So you can see that the head loss across the system, the energy that we lose from the water to flow through that sand, that requires energy to kind of force the water through that sand. When the water on this side, there's a little overflow here on the back. Let me get a little picture of that. And so that's the water's coming out. We have a little reservoir and there's a pump in here, and then that's pumping the water back to the other side and maintaining a constant head. So this level and this level are not changing. And so for a flow model, for a 2D flow and a flow net, we're going to be referring to the flow net equation. So this is the flow volume. So that's capital Q for us. That's a volume. So centimeters cubed or milliliters. Of course, those are the same thing. Times the length. So for the problems you work in lecture, the length is into the page. And for us, the length is into the page. No, it's the length. This is the length, this dimension. So like into the page. So if you look on the sketch, that happens to be 15 centimeters. So we have the flow is the length times H sub L. That's the head loss across the system, times the hydraulic conductivity. So that's the K value, or sometimes it's called permeability, times the number of flow channels. So let's make sure this is, this is channels, not lines. It's flow channels divided by the number of drops times the time it takes, to gather that flow, for that much flow to go through the system. So on your sketch, we have a steady state happening here. We don't have, this is a constant head. And so we've made some measurements for these conditions, and you need to transfer these measurements onto your sketch so you can do some calculations. So the datum is the bottom of the model here. That's where we made all the measurements from. From the, the elevation head, from the datum up to the headwaters, 38.5. The thickness of the sand is 20.5 centimeters. The sheet pile extends 10 centimeters into the sand, and the thickness of the sheet pile, this way, its thickness is a quarter of an inch. So you need to have that, because you're gonna calculate the dry unit weight, and so you're gonna have to calculate the volume that the sand is occupying. So you're gonna have to account for the sheet pile that's in the sand. Okay, and the mass of the sand, I'll just write this down. The mass of the dry sand is 21,875. So the mass of the sand that's in here is 21,875 grams. From the datum to the tailwater, we have 23.5. So the difference in the water levels, that's the energy that's lost, that's required for the, to push the water through the system, happens to be 15 centimeters. So make sure you have those dimensions and sketch your flow net, because you're going to turn that in with the report. You're going to turn in your own sketch of your flow net, and you're going to do some calculations based on your unique sketch. They should all look the same, but get some practice drawing them. When I say they should all look the same, I mean, I want you to draw the flow net with 3 flow channels. So that means it'll have, this is a flow channel, 1 flow channel, 2 flow channels, 3 flow channels. So it has 2 flow lines, and that makes 3 flow channels. And since you're going to have to try to make squares in the figures that are formed between the equal potential lines and the flow lines, these should be squares. That'll dictate how many equal potential lines you draw. And if you draw the flow net reasonably well, you should have, when you draw in 2 flow lines to create 3 flow channels, that should make 6 drops. Okay, so this is an equal potential line. So we have 1 drop, that's an equal potential line, 2 drops, 3 drops, 4, 5, and then 6 drops back up to this final equal potential. Okay, so take a moment, draw out your sketch, get your dimensions on there, and then in the next video or a subsequent video, we're going to take some readings so we can calculate the hydraulic conductivity.